A company wishes to market a new phone. It consults a market research company. Based on its survey, the research company presents the phone company with a price-demand equation. X equals 20,000 minus 100 times P, where X is the demand, that is the number of phones the consumers will buy, at a price of P euros per phone. If P is greater than or equal to 0, write down an inequality for X. Well, obviously P has to be greater than or equal to 0. P is the price of a phone. That has to be some positive number. It can't be negative. Now if P is greater than or equal to 0, that'll tell us something about X. So let's rearrange this equation to make P the subject. So bring the 20,000 over, so that's X minus 20,000 equals minus 100P. So dividing by minus 100, we get P equals 200 minus 0.01x, and P is greater than or equal to 0. So this expression here must be greater than or equal to 0. So that tells us something about X. So let's solve this inequality for X. So if I subtract 200 from both sides, I get 0 minus 200. Now we divide both sides by minus 0.01. Since we're dividing both sides of an inequality by a negative value, it switches the direction to less than or equal to. So we have 200 divided by 0.01, 200 divided by 1 over 100, or 200 multiplied by 100. We get X must be less than or equal to 20,000. So X is the demand, that is the number of phones the consumers will buy. So X has to be less than 20,000 if P is going to be a positive number, if the price is going to be positive. Okay, so this has to be less than 20,000. If we were to take a value of X that's greater than 20,000, like if we say put in 21,000 here, we would end up getting a value of P that's negative, and we don't want that. Here's a graph of X equals 20,000 minus 100P. Now X is the dependent variable, so it's the vertical axis here. P is the independent variable. You can see that if X is greater than 20,000, then the value of P will be negative. So if X is anywhere along here, to find P we have to go horizontally across to the line and down, and you can see P will be negative. So we can't have values of X greater than 20,000. They all have to be between 0 and 20,000, and then we go across and down to read off what P is. P has to be between 0 and this value here. So P can be anywhere along here, but it cannot be greater than 200. If P is greater than 200, then X would be negative. X is the demand, and the demand can't be a negative number. The number of phones that people want has to be a positive number. It actually has to be a number between 0 and 20,000. So we forget about this up here. The phone company's finance department provides a cost function C of X given by C of X equals 120,000 plus 40X, where 120,000 euros is the estimate of all fixed overheads and 40 euros is the estimate of the variable costs, that is energy and materials, etc. Find the marginal cost dc dx. So straightforward derivative of this function here. If we differentiate 120,000 with respect to X, we get 0 because this is just a constant. The derivative of 40X with respect to X is 40. What is meant by this value of the marginal cost? Well, X is the demand, that is the number of phones the consumers will buy. So you can see that if X is 1, we have to add 40 onto the fixed overheads. So we get 120,000 plus 40. If X is 2, that is if consumers buy 2 phones, we have to add 40 plus 40 or 80 onto this. So we see that 40 must be the cost of producing 1 phone. So if X is 1, it's 40 euros. If X is 2, it's going to be 2 times 40 is 80. And it doesn't matter how many phones have been produced apparently. The cost per phone is going to be 40 euros, no matter what the demand X is. The overall revenue R is given by R equals X multiplied by P for making and selling X phones at P euros each. Express R in terms of X. Well, we can get P in terms of X from the previous part, so you can just look back to that. You'll see it's 200 minus 0.01x, and we have to multiply P by X. So if we do that, we get R in terms of x. If R is greater than or equal to 0, find an inequality satisfied by x. So the revenue is the income made. So we just multiply the number of phones by the price per phone, and that's the income for selling X phones at P euros each. And here we are setting the revenue to be some positive number. Of course, revenue has to be positive. We can't have negative revenue. So even if X is 0, the revenue is going to be 0. The minimum valued revenue can have is 0. So now we have to solve this inequality. This is a quadratic inequality. For convenience, I will rewrite this quadratic inequality with the x squared term positive, just for convenience. So you just multiply all this by minus 1. So this becomes plus 0.01 x squared. This term here becomes minus 200x. I've also written the x squared term first to get it into standard form. Multiplying an inequality by minus 1 changes the direction of the inequality from greater than here to less than. Of course, 0 times minus 1 is just 0. Now I've explained how to do these before. To solve this, we first of all solve the quadratic equation. 0.01 squared minus 200x equals 0. So forget the inequality, just consider this equation. Just replace this with an equals. Now fortunately, this is a particularly simple type of quadratic equation. There is no constant term, there's no c. We just have an x squared term and an x term, so we can factorize x out. So we can very quickly get the factors of this quadratic equation. So here are the two factors. One of the factors is just x, and the other factor is 0.01x minus 200. We use what's called the zero product rule here. If you haven't heard of it before, it's just what you've seen before. If you have a product of two things giving you 0, then either of them is 0. It's very convenient. So x is 0, or the other factor is 0. So if we set the other factor equal to 0, what do we get for x? We get 200 divided by 0.01. That's the same as 200 multiplied by 100, which is 20,000. The next thing we do is we draw a rough sketch of this expression here. Now this is a quadratic. I've deliberately made the x squared term positive, which means it's u-shaped rather than an inverted u. Cuts the x-axis at 0 and at 20,000. So just a very rough sketch just to get an idea of what's going on. So now we want to find the values of x that make this thing less than 0. We know the values that make it equal to 0. It's equal to 0 at 0 and 20,000. The values that make this expression less than 0 are the values of x between 0 and 20,000. So if we pick any value of x in here and plug it into this expression, we will get a number less than 0, because to read it from the graph we have to go down to the graph and read across, so we get negative value for this expression. If we call this y, then we have y against x, then y will be negative or equal to 0 for values of x in this region here. So this region here is given by this. Of course, if you don't want to draw the graph, you could pick a value between, say, 0 and 20,000, plug it into this and see if it satisfies it. You could pick, say, 10,000, plug it into this. If you plug in 10,000, you will indeed get a negative value. But the graph is the quickest way to do it. If 10,000 gives a negative value, then all the values between 0 and 20,000 will solve this inequality. Next, we want to find the maximum revenue. So here's the expression that gives us the revenue. So we want to find the maximum value that R can have. Remember, x has to lie between 0 and 20,000 for R to be positive. R must be positive, of course. We can't have negative revenue. So we need to look at the graph of this here. First of all, I'll just show you the graph of this. Now we can see that the x squared term is negative, so we have an inverted U shape. Of course, this is a quadratic, so the maximum revenue is the maximum value of this function, so we have to go across here to read off the revenue, which is on the vertical axis. It looks like it's 1 million actually. we can use calculus to do this problem. Of course, we could also realize that the maximum revenue occurs for a value of x between 0 and 20,000. So the maximum revenue occurs when x is 10,000. So we could just plug 10,000 into this here, and if we do that, we can get the maximum revenue. We know that the graph cuts at 0 and 20,000 from when we were solving the inequality, which was essentially the same as this, except it was an upright u passing through 0 and 20,000. So the roots of this, the values of x that make this 0, are the same as the values of x that made the other expression 0, which is just got by changing the sign of this thing to give us the upright u shape. Anyway, I'm showing the vertical line here at 10,000. So we want a line through this point that's parallel to the x-axis. So you can see it appears to cut at 1 million. So we have the tangent at the maximum point. If we want to do this using calculus, we have to get the derivative. The derivative of this function will give us the slope of the tangent. Set the derivative equal to 0 and solve, and you'll get x equals 10,000. So anyway, that's another way you can find the x value of the maximum point, and then we just plug 10,000 in here. So we calculate r when x is 10,000. Work this out and you do indeed get 1 million. So 1 million euros is the maximum revenue. Next, we want to fill in the values for r and c in this table. When x is 0, this is easy. Plug 0 in for x, we get r equals 0. Plug 0 in for x here, we just get 120,000. So we just have to fill up this table just by plugging successive values of x into both of these expressions. Straightforward. Now I'm just going to use GeoGebra to plot both of these, r of x and c of x. C of x is just a straight line. The net profit is given by P equals revenue minus costs. That makes sense. The revenue is the income that the company takes in for selling X phones at P euros each, and here are the costs of making X phones. So obviously if we take the revenue and subtract the costs, we get the profit P. So we want to use the graph to shade in the regions where a profit is made. So we want the revenue to be greater than costs. So we want to find the values of x for which this curve, the revenue curve, is above the cost curve. So for values of x between this value and this value here, we can see that the revenue will be greater than the costs. So for example, for this value here, whatever it is, it's a little bit under 6,000. The revenue will be greater than the costs. So the revenue minus the costs will give you the profit. So the profit will be this distance here, whatever it is, that's corresponding to this value here. Similarly, if we take, say, a value of x that's 10,000, then the revenue is obviously greater than the cost, and the profit is got by subtracting. Take r and subtract c. So for this part here, well, we could shade in this region, but this would be like the profit for all these values of x. Next, we want to shade in the regions where a loss is made. So x runs from 0 up to 20,000. So a loss will be made in this region here. This is where c, the graph of c of x, is above the graph of r of x. So if we work out r minus c for values of x in this region, from 0 up to whatever this value is, we will see that r minus c will be negative. So r minus c will be negative. So the profit is negative. A negative profit is a loss. So the profit is revenue minus costs. So that's the situation there, and we see it over here as well. for this region here, the cost function is above the profit function. So we've all this region here. So the maximum value we know is 20,000. Now I don't know what this value is. I've yet to calculate both of these values. But for any value of x in along here, then the profit will be negative. In other words, we will have a loss. Find the break-even points from your diagram. That is the points where no profit or loss is made. Well, I'm going to do this using GeoGebra, and then we'll do it using calculation. So the break-even points are the points of intersection. So here they are. The x value of this point is 788.9. The x value of this point here is 15,211.1. So now we're going to do this algebraically, so we have to set r equal to c. So we want to find the values of x that give the same value for r and c, because then remember the profit is r minus c. But if r is equal to c, then r minus c is going to be 0. So the profit is 0 at those points. But the revenue and the cost is the same, so we make no profit. So we're going to end up with a quadratic equation here. So I've got it into standard form, get 0 on the right hand side. I've multiplied all of this by minus 100. And you know, you can try and factorize it, but I wouldn't bother. I just use the formula. Anyway, if we plug in here and simplify down, we end up with this thing. We get two answers, 789 or 15,211. So that's what we have in the picture here. The x value here is 788.9. Well, that's 789. This value here is 15,211. Find the maximum profit by using calculus or the graph. Well, P equals R minus C, so we take this expression here and subtract C. So we want to find the value of X that maximizes P. Well, we want to find the maximum value of P, so we could use calculus. And you know, to do that, we want to see where the derivative of this is 0. So we have to solve this equation. You could imagine a graph of this. This is the profit graphed out. And we want to find the turning point of the graph of this. Get the turning point by putting the slope of the tangent, the derivative, equal to 0. At the turning point, the tangent is horizontal. If we solve this, we get the x value of the turning point. It's 8,000. So we now take 8,000 and plug it in here, and that'll give us the maximum value of P. So just plug 8,000 into this, and if you work out all of this, you'll get 520,000 euros. So we see that when x is 8,000, we have a maximum profit. The revenue at 8,000 is this point here. The cost of 8,000 is this point here. And if we take this value and subtract this value, we get the length of this line here. This line here is the longest such line in this shaded region, you know. If we take this shaded region here, this is the longest such line. Its length is 520,000. So for maximum profit, X is 8,000. So this is the number of phones that have to be sold. From a previous part, we have the relation between X and what a phone should sell for. That's little p. Don't confuse it with this p here. This is the profit. Little p here is the price a phone must sell at for a given value of X. And here X is 8,000 for the maximum profit. So we just plug 8,000 in for X. We get 120 euros.